Welcome to this explainer. Okay, today we're tackling a totally massive hurdle in artificial intelligence. Teaching a machine to just see things, it's actually pretty easy nowadays, but teaching it to truly understand what it's looking at, that is incredibly hard. For years, we've celebrated AI's ability to recognize objects, but as we're about to discover, real visual understanding goes way, way beyond just pointing out what's in a picture. So let's do a quick play-along. Take a look at this diner scene right out of a movie and just notice how effortlessly you figure out the whole situation. We've got several people, plates of food, a server, and a guy on the right who is actively pointing at the man on his left. Now, if I were to ask you, hey, why is that guy pointing? Your brain literally goes to work instantly, piecing together a whole story that absolutely isn't written anywhere in those pixels.
You immediately just know he's likely telling the server that his friend ordered the pancakes. And you don't know that because of some written label, but through your own built-in visual common sense. You notice the server holding the food, you see the customer doesn't actually have his food yet, and you instantly understand the social dynamics of eating at a restaurant. You're reading intents, goals, and even the temporal context, like what happened right before this moment and what's going to happen next. To us, obvious. To an artificial intelligence, it's an absolute nightmare.
All right, here is our agenda for the explainer today. We'll start with the AI vision problem, move into visual common sense reasoning, then look at creating the ultimate test, adversarial matching explained, the R2C reasoning engine, and finally wrap up with humans versus machines. Let's get right into it.
Section 1. The AI vision problem. Okay, let's look at the fundamental limitation of current computer vision tech and define exactly what's holding machines back from viewing the world the way we do.
So here's the deal. State-of-the-art AI systems are fantastic at recognition. Spotting a plate or a cup, but they fail completely at cognition. Cognition is understanding the social dynamics, like who is serving whom. If you feed an image into a standard object detector today, it'll confidently draw little bounding boxes around the cups, the ties, the tables. It has totally mastered the nouns of the visual world. But it entirely misses the verbs and the underlying logic. It sees a hand in a plate, sure, but it doesn't actually grasp the concept of serving a meal.
Moving on to Section 2, Visual Common Sense Reasoning. To basically force AI to evolve, researchers realize something crucial. If we want machines to think like us, well, we have to test them like us.
Enter Visual Common Sense Reasoning, or VCR for short. This test demands that an AI not only answer a complex question about an image, but it actually has to prove its logic. It's not enough for the machine to just, get lucky and guess the right multiple choice answer. No way. It needs to show its work, proving it actually has a holistic cognitive understanding of what's going on.
The test throws down two strict hurdles. First, the machine's got to select the right answer. Pretty standard. But second, it absolutely must provide the exact rationale to justify why that answer is true. Only if it gets both the answer and the rationale correct does it actually pass. This two-part structure, answering, then justifying, makes it incredibly hard for an AI to just game the system or get lucky with a random guess.
And this setup brilliantly illustrates how researchers are mixing rich, natural language with explicit detection tags. They're creating this direct, literal link between the text and the visual objects. So instead of using clunky phrases like the man on the far left wearing the blue shirt, the questions use pointers tied directly to the image's bounding boxes, like person 1 or person 4. This makes sure the AI knows exactly who or what we're talking about, cleanly separating the challenge of simply finding the object from the real challenge of reasoning about it.
Which brings us to Section 3, Creating the Ultimate Test. Building a massive dataset to test common sense is no small feat. It required thousands of highly specific, thought-provoking images, and rather than using boring, static stock photos, the team extracted 110,000 unique movie scenes. They used an interestingness filter to capture really complicated human moments. Think about it, a static stock photo of an apple on a desk, that doesn't require any deep reasoning. But a movie scene, like a close-up of someone preparing a syringe, is just dripping with context, tension, and narrative. Movies are explicitly designed to show, not tell, which makes them the absolute perfect playground for testing visual common sense.
From these scenes, crowdsourced workers generated a whopping 290,000 multiple-choice questions. And the variety here is just staggering. 38% are explanatory why questions, and 24% focus on activities. The AI is even asked to reason about what people are actually thinking. That's the mental category, sitting at 8%. It has to guess what happens next, representing temporal reasoning at 13%. It's essentially asking machines to step into our shoes and read those invisible social scripts that govern our everyday human lives.
All right, Section 4, Adversarial Matching explained. But here is a massive, massive challenge. How on earth do you write wrong answers that actually trick a supercomputer without giving away subtle linguistic clues?
The ingenious solution they came up with is a technique called adversarial matching. Look, in the past, when humans wrote fake answers for multiple-choice datasets, they unknowingly left behind little patterns. Maybe the wrong answers were always, slightly shorter, or they used specific negative words. AI is notoriously good at spotting these lazy patterns and basically cheating the test, kind of like a student just guessing C because they haven't picked it in a while, without even reading the question. Adversarial matching completely eliminates this cheating.
It works like a brilliantly devious multiple-choice test. By recycling perfectly good answers from other questions as highly relevant distractors, it forces the AI to actually think. Here's the magic trick. Every single wrong answer on the test is actually a correct answer stolen from a completely different question. Because every option was originally written by a human as a true fact, the AI cannot rely on linguistic bias. The choices are all perfectly valid, well-written sentences. It mathematically guarantees that the only way to get the right answer is to look at the image and actually understand the context.
Section 5, the R2C Reasoning Engine. To establish a baseline for this brutal new test, the researchers decided to build a brand new model called the Recognition to Cognition Network.
The R2C engine mimics human thought in 3 distinct phases: grounding the objects, contextualizing the scene, and actively reasoning over the combined data. First up, the model grounds the text, so it matches the literal words person 1 to the actual bounding box of person 1 in the picture. Next, it contextualizes by looking at the rest of the image. It notices the pancakes, the server, the hand gestures. Finally, it uses a reasoning module to combine those language and visual cues to infer the social dynamics. It is a really structured attempt to teach a machine how to bridge the gap from simply seeing to actively comprehending.
And finally, Section 6, Humans versus Machines. So we've got the ultimate benchmark, and we have a custom-built reasoning engine. The big question is, how did state-of-the-art machine learning actually perform against real humans on the VCR test?
Well, the results are a bit of a reality check. While basic AI hovered around 45%, the custom R2C engine hit 65%. But both fell massively short of humans, who easily scored over 90%. And it gets crazier. When you combine both the answer and the rationale, because remember, the machine has to get both right to pass, the holistic score for the R2C engine drops to around 44%. We are still miles and miles away from an AI that can simply look at a picture and instantly understand the human story unfolding within it.
This tells us that the challenge of visual understanding is far from solved, and that true cognitive reasoning, that remains a distinctly human superpower for now. When we look at this diner scene, we don't just see pixels or bounding boxes or labels. We see a shared human experience. We inherently understand the complex, unspoken rules of our world, and figuring out how to encode those rules into a machine remains one of the absolute greatest frontiers in computer science. Which leaves us with this final provocative thought about the road ahead for artificial intelligence. We've totally conquered recognition. A machine can tell you a coffee cup is a coffee cup all day long. But cognition, the why, the how, those invisible strings tying our social interactions together, that is the next great leap. Thank you for joining me for this explainer, and I really hope this visual breakdown has helped you see the future of AI in a completely new light.